This is a quick video relating a problem, really the basic fundamental definition of voltage, where voltage is equal to the energy in joules divided by the amount of charge in coulombs. And basically we're talking about, how much energy it takes to move a certain amount of charge. And so that is defined in terms of voltage. And I want you to be thinking of voltage as a potential difference between two parts. And it takes a certain amount of energy to move charge apart. And so that sets up this potential difference. So let's work through this problem and see if this helps you. So here's the problem. The question was asked, how much energy in millijoules is required to move 100 millicoulombs between the terminals of a 1.5 volt battery? Now, admittedly, this, seems a little bit abstract in terms of us, being able to touch and feel and see this, but it's really just trying to get us to understand these relationships with these fundamental equations with voltage and current. And so one of those equations, and I'll try to see, let's see if I can find a number for it. And, again, okay, so this is chapter 2, equation 2-3. Okay, so it's equation 2.3. And, we do miss things in online courses, but one thing I would really emphasize to you guys, if we were in person, is how much this stuff is equation based. I am really a stickler in requiring you to develop these equation sheets. We have those. Actually, there's a very good equation sheet that comes with your textbook. And I don't see any real purpose in memorizing these, verbatim, but some of the fundamentals, it's just good to know them. I think with the access that we have to information, that, just knowing how to manipulate the equations and what they stand for is the most important thing. So when I look at this, I have 3 variables. I have V, and that is voltage. And I want you always to think of voltage as the potential difference between 2 points. And there is, between a positive and a negative area, there's a potential difference set up between those 2 areas. And there's an attraction, between that. And it is what voltage is defined as. And I guess another way to think of that is, voltage is this field, so to speak, that causes this attraction to happen between charges. And to move charge within a field, it takes a certain amount of energy. And so that's what this equation is defining. And so the W here, and if we saw this in the textbook, we'd see it's in italics, but it represents joules, which is our basic fundamental measure of energy. Okay, so a certain amount of energy is required to move a certain amount of charge. What's this charge? And it's measured in coulombs, named after a man whose name was Coulomb, and that was in your textbook as well. But anyway, this is charge, right? This is amount of charge, positive charge, negative charge. It's an amount. And so as I look at this particular problem, what he's asking for is how much energy. So I have the right equation to solve this problem. So what I need is my equation in the correct form, which I need it in terms of energy. And to solve that for W, I multiply both sides by Q, and I end up with this version of the equation. Excuse me. Now, when I get to that point, it's one of those situations where, I basically just need to enter the correct numbers with the correct values, recognizing metric prefixes. So if I have 100 millicoulombs coulombs, I have to recognize that that is 100 times 10 to the negative third coulombs, okay? So that's, that's another part of this. Make sure you're good with these metric prefixes. So I'll go ahead and enter that as 100 times 10 to the negative 3. Of course, on my calculator sequence, with me using a TI-84 plus, that's going to be, to get to that, that's going to be second function EE minus 3, right? To get there. Of course, I think you know all that. And so once I get to that point, it says the voltage that I have available is 1.5 volts. So I put that in, just 1.5. Let me do that better than that. 1.5. Then I'm going to enter that in my calculator. And when I enter that in the calculator, I'm going to enter that as 100 second EE minus 3 times 1.5. And when I do that, I get, and I've got my calculator set up to display in engineering notation. So I get 100.0000 E minus 3, right? So probably I could set this up to just 2 decimal places of accuracy to be better. And I know that this minus 3 is written as millijoules, right? So that's the solution to that problem. Again, making sure you have access to the equations. I recommend you make an equation sheet, because making the equation sheet just makes you aware of these equations, and I think it makes them easier for you to work. Additional questions on that? Anything you don't understand? Just please let me know.